Hi, in this video I will talk about semiparametric or semiparametric. Semiparametric estimation methods for expected shortfall. I will present two different methods, but they are related. But for the first method, now suppose these are the data that you have on losses, right? Then RT defined by this, right, are the returns. All right? I'm sure you know that. So this is the definition of a return, right? Now I'm going to suppose that the returns RT is a heavy-tailed I will explain what this means in a minute. It's a heavy-tailed process. So a process is said to be heavy-tailed if it satisfies the following conditions: that the probability that RT is greater than minus x. This notation means behaves as x to the power minus alpha times the function L of x as x approaches infinity, where the constant alpha must be a positive constant, and L of tx divided by L of t must approach 1 as t approaches infinity. Right? So let me put this in a box. So this, basically what I have written here is the definition of a heavy-tailed process. So I'm supposing that the returns of the losses are heavy-tailed, right? Okay. And by the way, the tilde, the notation tilde, means behaves as. All right. Now, in the next slide, I will show you the estimator for. So in this slide, I will show you the estimator for expected shortfall. So if the returns are T, are heavy-tailed, right, then the estimator for ES is given by the following expression. This is a big expression, so just bear with me. So it's the integral from 0 to p of the exponential function of L n p, I will explain what that is, divided by nq to the power 1 divided by alpha L n comma p comma n, right? Okay, then this whole thing here multiplied by r L n comma p, then close bracket dq, so integration is with respect to q, minus take away 1, right, where L and P denotes the integer part of the number n. N is the sample size plus P is the probability plus 0.05, right? And alpha Ln is given by this expression here, 1 over L times the sum 1 to L of the log of this divided by this to the power minus 1. And finally, these things here, these are the returns, arranged in increasing order. Okay. All right. So I know it looks like a complicated expression, but this expression gives an estimator for expected shortfall, where L and P is the integer part of this. Alpha sub L comma n is given by this, right? Okay, and Q here is the variable of integration. Okay, so this is one method. This is one method for estimating expected shortfall semi-parametrically. Okay. The second method for estimating expected shortfall semi-parametrically is as follows. So method number 2. Using the same notation. So under the notation of method 1, right? The estimator for expected shortfall is given by the following. Right, where f hat, right, denotes the okay, empirical CDF of the returns, right? And gamma hat is given by the following. Right, and k is a number between 1 and n. N is a sample size. Alright, so this is the second method for estimating expected shortfall semiparametrically. So this completes the semiparametric estimation of expected shortfall, and also completes the chapter on estimation of expected shortfall. In the next video, we shall start a new chapter which is entitled copula, right? I don't know whether you heard of the term copula, but you will know of that in the next video.